right, let's talk about the solutions for these. All right, so for the first one, check to see, can you remove any common factors? No. Are these the difference of two cubes or squares? Yes, these are both perfect squares. So what term can you square to get 9x squared? 3x, and to get 25y squared, you square 5y. So when you factor this, you get the sum of those terms, 3x plus 5y, times the difference of those terms. Hey, when you enter this online, I don't care what order it is. I'll always have both, like any of the orders are fine on those. Okay. For b, you have the difference of two cubes. So again, you figure out what bases are being cubed. We have an x and a -4. So the difference of cubes is going to have two factors, a binomial and a trinomial. The binomial is going to just be the sum of the terms, x plus a -4. The trinomial is going to be first term of x squared, last term of -4 squared. And then the middle term is the opposite of their product. So x times a -4, change the sign, you get a plus 4x. Okay. C, same thing. Again, look to remove any common factors first. There's nothing. You have the different, or the, in this case, the sum of cubes. So the base being cubed to get 8t cubed is 2t. The base being cubed to get 27 is 3. So when you look at your factors, you have a binomial and a trinomial. The binomial is just the sum of the terms, 2t and 3. The trinomial is the first term squared, so square the 2, square the t. The last term is the last term squared. 3 squared is plus 9. And then you take the product of their terms and you subtract it or change the sign. So 2x times, or 2t times a 3 is 6t. Change the sign, you get -6t. Okay, moving on to problem D. There's no common factors to remove, so you look to see, are the first and last terms perfect squares? We have x being squared and a 6 squared. And then test to see, if you take the product of those bases and double it, do you get this middle term, 12x? Yes. So you have a binomial square here. Your terms are x and 6. Your sign is whatever the sign of that middle term is, in this case a plus. Okay, do the same thing with your last example. First, remove any common factors. You can remove a 4 from the first two terms, but not the last one, so there's no common factors. So you look to see, are you dealing with two perfect squares at the beginning and end? We have a 2x being squared and a 5 being squared. If you take the product of these two terms or bases and double it, do you get 20x? Yes. So you have a binomial square. It fits the pattern. The terms are 2x and 5. The sign between them is whatever the sign is of that middle term. Okay. And so those are the factoring steps that you need to look for in these.